Good morning, class. Today we will discuss the numericals that you have unable to solve. As I have given you some numerical for your practice, you are unable to do the last one numerical, that is your fifth one numerical. So let's discuss the solution about the numerical number fifth. Now in that case, what is given to you, that is the cube, like this. That distance is 0.1 meter. From the left face is have the distance from these axes as 0.1 meter, whereas the side of the cube is given to you as well as 0.1 meter. What is the question? The question is to calculate the flux as well as the charge inside this cube. Now let's begin how to do this numerical. Here the magnitude of the electric field EF stands for electric field है on left face, right? Left face, that means this one, right? This one, left face is this one, right? So this is designated by EL, right? So first of all we have to calculate electric field, so that's why it is given as alpha x to u. Now what is the value of alpha given to you? That is nothing, that is of 500, right? So put the value of alpha, that is 500, and x, that means this much, this is of 0.1 meter. Now this point is to be eliminated. There are 10 and that comes out to be 50. So electric field on the left face, this is the left face, and electric field on the left face is to be, that is your 50, right? This is electric field. Now what do you want to calculate? You want to calculate the flux on the left face first of all. So as the flux formula says that E, because it is left, so that's why we will write electric field of the left face, and this is ds and this is cos of theta. Now area vector is somewhere here and electric field is somewhere here, so that's why cos 180 degree there be. So cos 180 is -1, so that's why we will write EL as its value is 50, and the ds is the area of the cube. Cube area is side into side, that is 0.1 ka square. Cos 180 is -1. So when you will solve this all, it comes out to be 50 into iska square is 0.01 and this is -1. So it comes out to be, that is your, how much it comes to be? It comes to be -0.5. You can solve it and you can see that this answers will be like this, right? Now similarly you have to calculate the flux on the right hand side. Now this one face is the this one face right hand side, right? Now electric field is in this direction as well as area vector have the same direction, so the theta is again 0 here. So for that phi r is equals to, that is ER ds cos of 0 degree. Now why 0? Because they have the same direction, so that's why again. Now whenever you are going to calculate the ER, here x is 0.1 because on the left face it is 0.1, but when you move to the right hand side, 0.1 plus 0.1 it becomes 0.2. So here it will be 0.2 and area is again side into side. Alpha is 500, so that's why we will write 500. ds, that is the area, that is side into side, that is, you can write simply here a square firstly, cos 0 is 1. So that whenever you will solve this, this comes out to be 100 a square, and 100 a is the side of the cube, that is 0.1, so that's why 0.1 ka square, that is equals to 100 into 0.01, and that finally comes to be 1, right? Now this is the 1 is the flux here, right? Now flux की यूनिट क्या होते हैं? That is Newton meter square coulomb inverse, right? Now whenever we will calculate the total flux, as the question is calculate the total flux, so that is your phi r minus प्लस होगा बट फिर बाद में साइन का वेरिएशन विल बी देयर. तो phi r is equals to 1 and phi l is negative minus 0.5. When you will solve it, it comes out to be 0.5 Newton meter square coulomb inverse. This is your flux. So what is the flux here? Flux is, that is your 0.5 Newton meter square coulomb inverse, like this. This is your total flux here, right? Now the question is, you have to calculate the charge as well. So charge, as by the Gauss law state that, what Gauss law state? That flux is always equals to Q over epsilon naught. So what is Q? Q is equals to phi epsilon naught. Flux, you have calculated it now, that comes out to be 0.5. Epsilon naught is 8.854 into 10 raised to the power minus 12. When you multiply these two terms, you will get the answer, that is 4.425 into 10 raised to the power minus 12 charges. So that's why it is coulomb. So this is the value of the charge. Okay, so this is the solution of this problem. I hope you people understand. Firstly, we have to calculate the electric field on the left phase, and then we have to calculate for the right phase, and then we have to add their flux, and similar way by using Gauss law we can calculate the charge. Most of the students are unable to calculate the question number 3 also. So here is the solution of question number 3. In the question number 3, electric field is given to you as 8I plus 4J plus 3K unit vector, and area is in which plane? XY plane. So that plane that will remain, XY is the plane in which area is included, and remaining plane is Z-axis. So that's why we include the unit vector of Z-axis. So flux formula is E dot S. That is your E is 8I plus 4J plus 3K, and S is the area, and area is given to you as 100K unit vector. As you know, I dot K is equals to J dot K is always equals to 0, but K dot K is equals to 1. So that's why only this factor will be multiplied, and your answer of the flux will be 300 Newton meter square coulomb inverse. So this is very easy question. I think ये difficult नहीं था. I don't know why you people are unable to solve this. Fine. So this is the questions that you are unable to do, and there is the solution of these problem. Now let's discuss the problems of the Gauss law. Gauss law problems can be solved. Let's see how you have to do the Gauss law. As Gauss law state that flux is always equals to charge enclosed by the surface over epsilon naught. Now let's see the questions that will help you to understand the concept more clearly. Let's say we have a charge plus Q that is present at the center of the sphere. There are two kind of sphere: concentric, that means the center is of same, right? These are the concentric sphere. This is your first surface S1, and this is your second surface S2. Now there is the radius. Here is the radius. First one is R1, and the second one having the radius R2, right? Now there is the charge Q present on the S1, whereas the charge 2Q is present over the second surface, right? Now your question is, what is the question? Question says that what is the ratio of flux? Now what is a ratio of flux in S1 or S2? And the second part says that S1 flux of S1 will change if dielectric medium is inserted. Dielectric medium is introduced in S1. ये आपको शो करना है that how the flux will change in S1. So let's begin with, first of all we have to calculate flux of the first surface. For first surface, that is for S1, flux will be equals to charge by enclosed by it over epsilon naught. This is the flux of the first. And for S2, it is, that is your, now previous one is also included because the center is same, so that's why it is also inside present. So that's why you will write Q plus 2Q over epsilon naught, that is 3Q over epsilon naught, right? So now in order to calculate the ratio, a ratio as our first part include that calculate the ratio between the flux. So that is phi 1 over phi 2. So Q over epsilon naught into phi 2 is epsilon naught over 3Q. Epsilon naught cut, Q and Q cut. So what is the ratio? 1 ratio 3 is the answer. Right, now the part second is quite difficult because it says if dielectric is inserted, dielectric stands for K is introduced here now, where in S1, then flux will change, let's say phi 1 dash. So according to the formula of the flux, that is E dot ds, right? Now we know, what do you know, that is K is always equals to, yes, dielectric constant क्या होता था, dielectric constant होता था, that is E upon E naught. This is your dielectric constant. So if here we have to calculate E naught, then it is equals to E by K. E naught is nothing but it is the applied electric field, here it is E, right? So we can replace it here by flux, that is E by K and ds. So K is the constant, K is the dielectric constant, you can take it out, that is E dot ds. And you can write E dot ds by the Gauss law as 1 over K Q over epsilon naught. So what is the flux change? That is Q K epsilon naught. This is the answer, right? This is the way you have to calculate the flux here. What is the introduction of dielectric flux? How the flux will change if the dielectric is going to be introduced here? So in this way, the dielectric is going to change the flux of the sphere S1, right? Now let's consider the second numerical number 2, that is based on the Gauss law. Let's say we have a kind of cylinder here kept. Let's say this is your cylinder that is kept here. Now length of the cylinder is of 1 meter, right? And the distance of this is also going to be 1 meter. Now this is your x-axis, this is y, this is your z-axis. Here area of the cylinder is given as 25 centimeter square, right? Electric field is also given to you, that is 50 xi, means variable electric field is there. You have to calculate, what you have to calculate? Calculate the flux through the cylinder, flux of system you can say, right? And the second is charge of cylinder. Similar question like that of the cube. Now let's calculate. First of all, as we know that electric field is going like this and the area vector is going like this, so there is the angle of 180 degrees. So one thing is always known to us, that is the electric field through a curved surface is always equals to 0. So there is no need to calculate here. You have to calculate here only. Okay? For the left face, right? Electric field for the left face, that will be equals to, that is 50, because the electric field is given to you na, 50 x kitna hai, x is 1, so that's why it is 50, right? Newton per coulomb. Now flux is, that is EL S cos of theta. Now for this, cos is 180 degree, as electric field goes like this and area vector goes like this. So angle is 180, so that's why EL is 50. Area of the cylinder is also given to you, that is 25 centimeter square, and centimeter is being converted into meter, so that's why 25 into 10 raised to the power minus 4. Cos 180 is minus 1. So how it is come now to be, this is will be equals to minus 1250 into 10 raised to the power minus 4 Newton meter square coulomb inverse, right? Now similarly, flux on the right hand side, again it is ERS cos of 0 degree. Now in this case electric field is here, area vector is also here, both here in the same direction, so that's why it is going to like this. Now ER is equals to, that is 50, okay, 50 into, now the distance 1 meter and this is again 1 meter, that is going to be how much, this is of 2 meter, so that's why 50 into 2 into area is 25 into 10 raised to the power minus 4. So it comes out to be how much, 2500 into 10 raised to the power minus 4 Newton meter square coulomb inverse, right? So this much. Now we have to calculate the flux, total flux. So total flux will be phi is equals to phi r plus phi l. So what is the value of phi r, that is 2500 minus phi l is 1250 into 10 raised to the power minus 4 is common to both of these. So when we solve it, it comes out to be 1250 into 10 raised to the power minus 1 Newton meter square coulomb inverse. Now in order to calculate the charge, we have formula phi epsilon naught, that is 8.854 into 10 raised to the power minus 12 into 1.250 into 10 raised to the power minus 1. So when you will solve this, you will get the answer 11067.5 into 10 raised to the power minus 16. And when you move the point, the charge will be there to you, right? So this is what we have to calculate, as this is the charge, so that's why the unit is coulomb here. So these kind of the questions will be asked to you in a paper, right? Now let's discuss the topic, that is your deduction of Coulomb's law from Gauss law, right? We have to discuss this topic. Last topic, let's discuss. Let's say we have a charge Q1 here, right? This is, now Q1 charge is there, so that's why it included electric field like this, right? Now let's say a small elemental area is here of the big sphere like this. This is small area. Let's say another charge Q2 is present somewhere on the elemental portion, that is Q2. Let's the distance between these two will be R, right? Area vector obviously is going like this. Okay, now here E or ds are in the same direction, so theta will be 0. Now by Gauss law, because you have to use of Gauss law, you have to derive Coulomb. So Gauss law said that flux, that is E dot ds, is always equals to charge, that is Q over epsilon naught. But this one charge is Q1 over epsilon naught, right? Now this can be written as EDS cos of 0 degree, that is Q1 over epsilon naught. Cos 0 is 1, so no issue. This comes out to be Q1 over epsilon naught. Because it is a Gaussian surface, and Gaussian surface is the one in which electric field is constant, EF is going to be constant, right? So that's why electric field is going to be constant. We have to take it out from the integration. We just remain with EDS Q1 over epsilon naught. What is the surface area of the sphere? That is 4 pi r square, and this is Q1 over epsilon naught. So what formula you will get for the electric field, that is 1 over 4 pi epsilon naught q1 over r square. और वैसे भी इलेक्ट्रिक फील्ड जो होती है एक पॉइंट के लिए वो यही फॉर्मूला उसका होता है, राइट. But this is the electric field of this charge, that is q1 at the point q2. Now as this charge will experience the electric field, so that act as a source charge and this charge will act as a test charge. So this test charge will experience a force. That force is given by F is equals to Q2E, right. So what is Q2? Q2 is as it is, but what is E? That is 1 over 4 pi epsilon naught Q1 over R square. So force will be equals to 1 over 4 pi epsilon naught Q1 Q2 upon R square. This is what? This is nothing but this is the Coulomb's law. Now this can be question कि ये कहाँ से आया? So again I am going to tell you, as Q1 experienced the electric field and due to its electric field this charge will experience a force, and that force is given by F is equals to Q2E. Where it comes from? It comes from E is equals to F upon Q. So F will be equals to QE. So that's why we have written it like Q2 and E. I hope you people understand how we have derived the Coulomb's law by using the Gauss law. This topic is also important, and that's enough for today. Thank you and have a nice day.